I asked you actually a question at the beginning, which is saying what is the best security approach to set versus a database-based project or database a project running databases in background. Uh, Usually, such a question does not have a one unique and unified answer, but we have to know the services delivered, and based on that, we talk. But since we talk about the security of databases, the physical architecture, the physical segregation of the data store from the front end interfaces is the first security measure to set. So, as a first solution, physically we segregate the data store, which is the DBMS, from the front end interfaces. First approach. The best, regarding the best, so it depends on the of the system running, the project running the requests and the responses of the database management system. If you are willing to have the database to run for delivering local services to local users. It's not the same when we talk about the database, we deliver services to the www environment users. It's not the same scenario. But it's a public environment and this is a private environment, so completely different. And the considerations, they are completely different. The privacy in the local environment is much more, let's say, protected and guaranteed, and so on. So there are considerations we have to tackle to say what is the best. But we may start as an answer, we start with the physical segregation. Then after we give actually sessions and privileges to different activities for the DML or the DDL, and we can use the triggers to control that. We can actually set all the transactions to be considered only using transaction, the T-SQL queries only, T-SQL transactions, sorry. There will be no query to be standalone query to execute on the data store on the database. Only T-SQL queries to secure and to guarantee that everything is covered. And we have to manipulate the T-SQL from all perspectives, even to generate the CLR SPs, which is a combination of the front end, the stored procedures, and stored procedures, the stored procedures, and the back end stored procedures, the CLRs. So in all cases, physical architecture, then securing the queries and responses from the front end to the back end solution. Since we talk about this physical segregation is the security. So on top of that, we have to secure the transactions. And every query has to be set and submitted within a transaction in order to guarantee the highest security level. So for this purpose and for this regard only, we may talk about securing database-based project. And this is the best overview. And this is the summary that you can consider from the beginning of this semester up to today. How and what is the best, is the first security approach. All of those considerations, questions, you can answer now. And this is the answer actually I've given you. This is recorded for your reference future time. Okay. So before we start this chapter number 5, actually this unit number 5, which is talking about the security side, sorry, of the SQL Server. Let's have a small look and a small recap on what was the chapter 4 about, because from there only we are going to start the security, the SQL Server security. We will not be able to talk about the SQL Server security, which are the themes or whatever the consideration we're going to discuss. The solutions adopted for security measures by Microsoft, unless we know the summary clearly of the 4 first units. The last one from them is the chapter number 4, which is this working with transactions. So the working with transaction is a summary chapter here, which we see a recap of adopting transactions for different purposes. The security measure considered here is how the transaction would run what are the elements, and what are the constraints, external constraints. So regarding the how, actually we talk about what are the queries inside, whether it is one or many. So based on that, based on the number of the queries, there are properties to be adopted. Here we talk about the asset properties. Every single T-SQL transaction has to obey to the asset, otherwise we do not guarantee, or developers do not guarantee the well state of the transaction. This is if the asset, the properties did not get respected by a given transaction, or at least one of the asset properties, not all of them. Atomicity, consistency, isolation, durability. Okay. Beside of the properties that they have to be actually adopted on top of each transaction, and each transaction has to obey to them and has to demonstrate that it is obeying to those properties. We talk about the modes. Means a transaction has to be seen being executed, and after that there is a mode to admit or to cancel what has been brought by the transaction. Here we talk about mainly we have 4 modes. The most complex one and the most actually utilized in public and let's say in a commercialized environment is the batch scoped transaction mode, via which we see 2 perspectives: the definition of the mass transactions and the non-mass transactions. Both of them are actually batch scope transactions. The mass transactions and the non-mass transactions, they are transactions via which we can or we cannot define sort of save points to control partially the transaction. When we talk about the non-merge transactions, so we talk about a long list of queries to be executed within the same transaction, long list of standalone queries to be executed within the same transaction here, the non-merge transaction. And here only we can create save points, which are time frames that we can refer to from within the body. So we are still inside the body here as per this example, and we are running back. We are running back to the save point number 1, and then after the transaction we continue. So those queries here would not be actually admitted because they are coming in between the rollback and the defined save point. So within the non-mass transactions here, batch scope and non-mass transactions, the definition of the save points or the time frame points, they are actually possible and can be done without any issue. Because if you can notice here, again, we insist, but there are only list of standalone queries within a non-mass transaction. Non-mass. Mass stands for multi-active result sets. But for the case of the mass transactions, the scenario is completely different. Here we cannot generate save points. Why? Because for the mass transactions, multiple active or multi-active result sets, we are having more than one command to be executed within the same transaction. And this is mainly not only clearly visible to us as users or developers as well within the .NET framework. Why? Because here within the .NET framework, we are able to point methods from within the same namespace. When considering this example here in front of us now, we are seeing command 1 being defined. Here it is. And this is the content of this command 1 from here, starting from here. Okay. Besides The second command, here it is, that has a different DML to be executed. Here it's a simple update, but whatever. It has different DML to be executed, data manipulation language query. Then after we define whether the .NET framework, we are defining a transaction. Here it is, the definition. And to this same transaction, the name here is user-defined. Run, it's user-defined. This user-defined name here, actually, it is utilized to link those two commands, command 1 and command 2. So command 1 and command 2, they are elements from the transaction run. What is run is the username, it's a variable defined, it's user-defined variable that it is actually a SQL transaction. So from within the transaction, I have actually a block to do. And at the end, the minute I'm going to pass to the end without any delay, we are having the transaction named run to be either committed with commit or rolled back with, yes, rolled back with a rollback. What is it? That is it. The question comes here, actually, what's the advantage? The second question is that, can we cancel the execution of the command 1, for example, and we execute only command 2 from within this transaction? Answer is no. Why? Because both of them, they are transaction 1. Sorry, they are a transaction. So transaction means both commands. In this example here, we have 2. And due to this view here only, saved points cannot be utilized. What is the proof for that? The sequential order of those CMD and CMD 1 and 2, the command 1 and command 2. Can we swap them? Absolutely we can. They are all inside what? Inside the try block here. So the sequential order for command 1, command 2 is not a question of interpreting the queries. Thus save points is not to be defined with the success within the mass transactions. In conclusion, mass transactions or non-mass transactions, they are both of them batch scope transactions. The transaction mode is batch scoped. Okay, catch block in case of exceptions. Actually, the transaction properties that we have or features that you have to respect in order to elevate the transaction security is the isolation level. Here we saw that due to the usage and the congestion of the use of the service, the delivery of the service provider, whatever, the resource, during the peak time, there are runtime issues. They are not due to the development. They are not due to the implementation. They are not mandatory to be source code issues. Dirty red, non-repeatable red, phantom red. Those are actually kinds of let's say, considered issues in the live flow. No need to redefine them again, but here we talk about values being displayed in an erroneous way. Example of just one terminology that I'm going to define it here. I'm not going to give any example because we saw the example. The terminology I'm going to define to you, we saw it, but here is a small recap. The deadlock status, via which we can see objects from within a transaction being locked. They cannot be utilized by other transactions unless the given transaction is terminated. Here we talk about the serializable transaction mode. So in the case of, we are, for example, make an update and the insert of 2 entities. unless your transaction finish and updating and insert new values and the given entity, there will be no chance for the other transactions to use those two entities if the transaction mode is serializable. Here, in conclusion, just without delaying and without making the thing long, transaction or transactions, isolations, levels, they are put into action for the purpose of eliminating the runtime issues happening to the data flow. When we say actually runtime errors happening due to the data flow, what does it mean? What errors to happen due to the data flow? Mainly we talk about the congestion, paths and directions where the resource has to reach and so on. So those are kinds of issues to happen within the runtime. A very simple example via which we are generating a transaction. Here it is. We are having 4 queries to do. And one of the queries we defined earlier, and still we are using it in different transactions, the wait for delay function. The wait for delay function. So the wait for delay function. So this is a function where this is a procedure where actually we are able to make the transaction be stopped for a certain period of time. And this example here we see seconds, which are 10 seconds, minutes, hours. So here we are talking about 10 seconds of wait time. And during this time, the full time here, according to the transaction generated earlier, which is the serializable, will not be seeing any other transaction capable of using the test table or any other table that can be utilized from within this same transaction body. Why? Because it's deadlocked. Deadlocked. Such scenarios actually they are concerned of runtime runtime errors due to the congestion. What does it mean? Can you expect for example, phantom red, the values to be displayed in an erroneous way? User 1 asks a session and it has to, and the system displays the values of that session to user number 2. Such an error, do you expect it to happen for a system that runs 10 users or 15 users or 20 users? Can you answer the question? Are you with me?
No, mister.
I said?
Yes, mister.
I said, yes, I said. The context of the, yes, the runtime issues to be solved, whatever the runtime issues, what are they? The phantom red or the repeatable red or the dirty red? I given the example of the phantom red where values session number 1 gets displayed for session number 2 by error due to the, these runtime issues. Do you expect such behavior to happen in a system where 10 users they are using the system, or 15 users are using the system, or 20 users are using the system? How many? Which group? The 10 users, the 15 users, or the 20 users? Case at that time the system will will call this sort of failure, the phantom red. There is no doubt, and clearly saying, and we clearly explain, such scenarios happen in the environment which is too much congested. In the sense, web-like WW environment is one of the very famous examples where we see service providers being utilized by thousands and thousands, if they are not hundreds, thousands and millions even, of users at the same time. At that time, we may talk about the issues defined here, the phantom red, the repeatable red, or the dirty red. Any questions you raise here, please? The last consideration for the transactions in plural, is that we can generate distributed transactions using predefined keywords, and through which we indicate that the transaction, this distributed one, can incorporate parties from different, let's say, instances from different objects, even geographically segregated. Begin distributed to indicate that we are referring to a distributed transaction. And within the same body of the transaction, we may call more than one instance from different objects at the same time. Have more reading regarding this context of distributed transactions. Any questions, please, before we pass to unit number 5?
No.
Okay. Okay, let's pass to chapter number 5 and the context of the SQL Server Security, the SQL Server Security. At this level, we are going to see dedicated security measures set by the Microsoft in order to secure its famous kit, the SQL Server. We'll be able to see the theories defined in the security measures, security considerations. We will also be noticing the importance and the need of the transactions that are using remote resources. And we are going to tackle .NET solutions via which we see the secure coding via which we eliminate issues, and we make the run and the use of the database in question is more secure. So first actually, let's say, frame approach via which we can correlate the ideas behind of this chapter, server security. What does mean server security? If we are talking now about the SQL Server Security, so what were we doing since the beginning? All is concerning the SQL Server Security only. Yet Microsoft actually, as a known of this SQL Server, have actually during the early age of the development of this SQL Server, we are talking precisely and specifically 2003 version, has brought into life a consideration of themes via which we measure the security of the given database management system. So the first security here actually to tackle for this purpose, when we define, literally speaking here, SQL Server Security, are the themes via which we see the given, let's say, database is being secured. Themes may adopt one or many as the request is requiring. So still we'll be talking about the secure code, and only still we'll be respecting all the transaction properties and features. We'll not omit anything. It's a continuation, no more, no less. The four themes actually defined here and presented to us in order to um, to discuss the SQL Server Security. They are the following: the security by design, designing the project, and immediately you have to think about the physical architecture. Immediately you have to think that you are going to segregate the back-end store from the front-end interfaces. The second theme is the security by default, or secure the database by default. Means every task you do inside the database has to be secured. Otherwise, fully is isolated. Third theme is security, or securing the database or the DB by deployment, in the sense of once the implementation and the test has been accomplished, at that time when deploying the database to the public, from the private environment to the public environment, from the local DB to the let's say to the online DB, or from the offline DB to the online DB. At that time, we talk about the security measures to be adopted. So security by deployment. Fourth theme, number four theme, is the security of the communication channels. SQL protocols used to communicate with front-end interfaces. They are questioned to guarantee that the transactions being secured when communicated. Whenever they are communicated, or they are communicating with the respective parties, internally set or externally even. So the security by communication, or the secure communications. Let's define those four themes clearly and specifically. Concerning the the theme via which we see database management system securing a database by design, here we will be actually having a good consideration that the SQL Server is considering the physical approach. What does it mean? It means all the database will be accessed remotely. Simply, all the databases would be accessed remotely, and the SQL Server will filter all the queries. This since the actually whatever, this is actually one of the very famous approaches that the SQL Server was successful in guaranteeing since the early age. And it is not the final. So the SQL Server as a framework is considered that the security by design is one of the considerations, but it is also the role of the developers to consider to implement the interfaces to isolate the requests from being intercepted or interfered. Here, and when we compare this security by design to the secure by default, so when we talk about the theme that the security is seen when by default, what does it mean? Actually, this is an experience via which maybe developers, maybe users, they are going to experience this secure by default during the installation of the SQL Server, during the deployment of the, not the deployment, but during the, the installation mainly of the DBMS, the database management system. At that time, they will experience clearly the security set by the SQL Server, how to install, what are the features to set, what are the preferences to allow, what are the preferences we do not need to allow, what are the preferences you do not have to allow, and so on. So we talk about the default security level. Here it's a theme, it's an approach, it's a behavior that on the database will be running with its consideration. The third theme, which is actually to see a database being secured by deployment. It is actually to talk about the security when exporting the database from either the local DB or offline DB to an online DB. Simple. So to the run or to the production environment. When delivering a database to the production environment, and we set up or we tackle the security at that level, we talk about the secure by default by deployment theme. You remember that the deployment needs from the developer, let's say the database administrator has to generate a snapshot, number one, snapshot number two, and then a change script, and the change script will decide whether the database needs to be deployed or not, based on its termination or accomplishment status. And one of the very famous and very sensitive and critical secure theme or the security themes that we have to adopt on our transactions is the security set on top of the communications. Here, clearly and literally speaking, communications happening between the front and the back end has to be secured in order to has to be secured in the sense of be isolated, for example, from being intercepted or interfered. To take an example, actually, how we talk about the communication, because actually remember all the security measures to set on top of the network. It is a considerable, let's say, view or overview, because communicating between the front end and the back end solution, it is a network communication. It is a remote communication. Actually, interferers or attackers will clearly see that A, which is the interface, the front end, is communicating with the B, which is the back end. So this would happen actually by controlling the users and the sessions using the product or the service. This happens and be successful by controlling the users and the customers utilizing the service, which is the database with its content. Because actually, without actually discussing a lot of the technical approaches, what does mean securing security communication, because you have to know all of them. You have to know what are the injections, what are the middle or man in the middle attack types, categories. All of those we saw in the cybersecurity and in the computer security course. A small recap on what we saw so far. Actually, remember that the more you have actually as entry points, means holes or doors that leads to the flow to be in and out, the more the environment is vulnerable. Vulnerable to what? Vulnerable to a threat, and this threat is a question of recognizing what is the weakness. But in all cases, the interception or the interference might happen. Yeah, the more those you have in your, let's say, environment or framework, the more opportunities in an intruder has to break in, or can be, or leads reach to breaking. From another perspective, from another view, actually, if we discuss security-wise, what is a transaction? We know that transaction is it's an obscure layer via which we see group of queries, maybe one query only, being transmitted, and we see response or responses being also retrieved. That is a transaction, and that is what the transaction is for. But when we discuss what is a transaction in terms of security, and specifically security themes, we see something like the graph here in front of us. We see the segregation of the devices where the database might reside in. And we see sessions and privileges being awarded to end users. And we see procedures here to either give the permissions to all or to deny all, or you may control, which is the context of the access control here, the procedures, the access control. When we say that group number one is not allowed to make any insert, so this is an access control. Is a right to do or not to do. Group number two has not the right to update, for example. This is another sort of restriction, and this is another sort of access control. Any questions, please, at this level?
No, Mr.
No, Mr.